Hello everyone, we are from Class 7B2A, Group 4, and we are going to share the outcome of our group project, evaluation and enhancement of road safety features. These tests aim to evaluate skid resistance for safe braking, assess surface texture and drainage to ensure grip and comfort, and determine pavement condition like roughness and where to support maintenance planning and meet safety standards. The site that we chose to do the testing is located in between Block 1 and Block 2 of Faculty of Engineering, UIT M. Shah Alam. The reason that we chose this site is because it consists of three main surfaces, which are smooth surfaces, medium surfaces, and rough surfaces. Next, we will be talking about the apparatus needed for the tests carried out and the procedures. For the first test, we will be carrying out the skid resistance test. The apparatus needed for this test is skid resistance tester. Next, we will be talking about the procedure. First, set up the skid resistance tester. Make sure the center column is vertical by adjusting the 3 leveling screws. Next, adjust the pivot height so the arm swings freely through its arc without touching the road. It should swing past 0 on the scale. Then lower the pivot until the rubber foot touches the surface over exactly 150 millimeters. Use a scale rule to measure this. Raise the pendulum arm to the starting position and lock it with a retaining catch. Now, wet the road surface at the exact spot where the test will be done. Check that the pendulum can swing fully and smoothly. Make sure there's no obstruction. Release the pendulum arm and let it swing to contact the road surface. After the swing, catch the arm to stop it from swinging back and affecting the reading. Read the value on the scale where the pointer stops. This is your skid resistance reading. This is us carrying out the test. Next, the sand patch method. The apparatus needed are a brass cylinder, sand brush, sand spreader, and a steel ruler. Start by making sure the test area is clean, dry, and free from dust, grease, or debris. Fill the brass cylinder with sand, then level off the excess at the top. Gently tap the cylinder 3 times on a hard surface. Refill and strike off again if needed. Pour the sand onto the test surface in a neat pile. If it's windy, shield the area to avoid sand loss. Using the sand spreader, gently work the sand into the surface in a spiral motion. Keep going until the patch is even and the diameter no longer changes. Measure the diameter of the sand circle for evenly spaced points. Round each to the nearest 5 millimeters and take the average. Once done, sweep away and discard the used sand. Repeat the entire process at 2 more test locations for accuracy. This is us carrying out the test. On to the final test, surface drainage test. The apparatus needed are an outflow meter and a stopwatch. Next, the procedures. First, place the outflow meter firmly on the selected test surface and ensure it's stable. Fill the outflow meter with exactly 300 milliliters of water. Release the stopper and start timing. Record how long it takes for the water to fully drain. Repeat these steps on 3 surface types: smooth, medium, and rough. Here are the results obtained and the standards that can be used as a reference. The results obtained are well within the Malaysian standards taken from Aerotechnic Jalen and JKR standards. For skid resistance, on dry surfaces, skid resistance was generally higher than on wet. The smooth surface showed the highest skid values to 135 dry and 112 wet, while the rough surface had the lowest. However, the smooth surface also experienced the largest drop when wet, which could increase skidding risk in rainy conditions. For the sand patch method, the measured mean texture depth was highest on the smooth surface at 22 mm, followed by medium at 18.6 and rough at 16.6. This result is unexpected, as rougher surfaces typically show higher texture depth. The difference may be due to measurement variations or human error during testing. Drainage times show the rough surface performed best, draining in just 5.67 seconds. Medium and smooth surfaces took longer, 6.3 and 6.57 seconds, respectively. This confirms that rough textures allow better water flow, which supports safer driving in wet conditions. In conclusion, skid resistance decreases on wet surfaces, increasing the risk of skidding. The smooth surface was most affected, dropping from 135 to 112, while the rough surface drained water fastest at 5.67 seconds. It showed the lowest skid resistance. Mean texture depth ranged from 16.6 to 22 mm, but more study is needed to confirm a clear pattern. Overall, maintaining proper surface texture is crucial for road safety, especially in wet conditions.